In the previous chapter, we talked about the combinational logic circuits. And in the combinational logic circuits, we learned that using three basic gates and or NOT gates and also XOR NOR NAND gates, we could design the combinational logic circuits. In the combinational logic circuits, the output of the circuit, the value of the output, was the function of value of the current input. Now, the difference between the combinational and sequential circuits is that in the sequential logic circuits, the output of these circuits depends on its state. In other words, we can say that the output of the sequential circuits is a function of the past input values, not only the current values. It means that we will have the feedback signal from output to the input, that we can determine the past input value and distinguish the value of the output. But in the combinational logic circuit, we learn that the output value is only depend on the current input value, not for the past value. Now, the two elementary sequential circuits are set reset flip-flops, SRFF, and toggle flip-flops. Flip-flops are the devices, or can be say that are the IC integrated circuits that can use in the sequential logic circuits. But what is the difference between the SR flip-flop and T flip-flop? Here, I would like to mention that we are more than these two flip-flops in the case of logic circuits and digital electronics. But for this course, we only want to learn about these two flip-flops. The set reset flip-flop is a basic memory element in many digital circuits. For producing a memory in our digital devices, we can use set reset flip-flops. In other words, we can say that a set reset flip-flop can store one bit in itself. Store one bit in itself. And in the case of toggle flip-flop, we can say that the TFF is a basic counter element. It means that using TFF, we can count something that we want to count it. For example, we can connect it to the sensors, different types of sensors that we learned in the previous chapters. So, and count the numbers that comes from the sensor to our circuit. Now, let's look at the schematic form of flip-flops here. This is the SRFF. The schematic form of the set-reset flip-flop is like that. We have two input, S as set, R as reset, and also we will have two output. Actually, these two output is one output because this is the Q and this is the Q bar. We know that if we have Q, we can calculate the Q bar. But for some application, we prefer to have two output as Q and Q bar in the SRFF as an output of these flip-flop. So we need to learn that in the case of SR flip-flop, we have two input set reset and two output Q and Q bar. In the case of toggle FF, we have also two inputs. The first one is transition signal, is for transition signal that using this signal or by this signal we can toggle the output. The meaning of toggle is the complement the current value, the current value of output. This is the meaning of toggle. If we say that we toggle something, it means that we complement this value. In the case of toggle flip-flop, we will see that if we have some feature in the signal that comes in at this input, we will toggle or we can toggle the output. And this C is the clear signal. I will talk about these two flip-flops in detail. The first one, that is the basic memory element, is set reset flip-flop. The circuit of set reset flip-flop is like that. As you see here, using two OR and two NOT gate, we can implement the set reset flip-flop. As you see here, at this circuit, we have the feedback signal. This is the feedback signal, and this is also the feedback signal. What is the meaning of this feedback signal? The feedback signal is a signal that connects the output or send the value of the output to the input. This is the feedback. It means that we can feed the signal back. Where is the back? In the case of circuit is the input. Let's investigate this circuit, and I want to show you that how does set reset flip-flop works. Let's explain this circuit. We said that for explaining and understanding the output of any circuit, we need to generate the truth table. The truth table for each circuit. Now, suppose that I want to know that if I have S and R, and also if I know the Q, in the current time, in the T time, and also the Q for T plus 1 time. The next value for Q, the current value for Q. I want to investigate this SRFF. Look at here. I can say that if I have 0 and 0 in the input, suppose that I have S is 0. We can say that each memory have three properties. The first one is hold. Each memory hold the information. Hold the information that comes in it. The memory can reset the information, and also the memory can set the information. Hold it, reset it, and set it. Okay, according to this knowledge, I want to determine the output Qt plus 1. Or I can say for this one Q current and this Q next. Both of them are right and are correct. Now, let's look at here. First of all, I suppose that Q is 0. I said that Q is 0. If Q is 0, what will be the Q prime? Say
1.
1. Now look at here. This one comes here, and this input will get 1. This input is also 0. What is the output of the OR in this case?
1.
1.
And then 0.
1. Yes, because this is the OR gate. One input is 1. It means that the output is 1. What about here, this output of the NOT gate?
0.
0. This 0 is the Q because the output is connected to Q. This 0 from this line and the signal comes to the input of this gate, 0. What is the 0? This is the 0. What is the value of S? 0. We said that's 0. What is the output? 0. What is the output?
1.
1. The Q is again 1. This one comes here. 1 again. 1 0 1 0 0. The next time, this is the next time. The next time again, ZQ. Now, if I suppose that QT, in the next time, QT plus 1 is also 0. This 0 again comes here, 0, 0, 0, again 1, 1, 1. It means that the QT plus 1 is 0. Now, if I suppose that my QT is 1, what is the QT bar?
0.
0.
0. Again, this 0 using this signal comes here. R is 0. The output is what?
0.
0.
0. The output of NOT is 1. This 1 using this signal comes to here. 1, 0, 0, 1. Output is 1. This output is 0. Again, QT 1, QT 1, QT 1 plus is 0. This 0 comes here, 0, 0, 0, 1. It means that QT plus 1 again is 1. What happened? We can say that if the current value of output is 1, this flip-flop stores this 1 in itself. It means that I can hold the value, I can hold the information. Now, let's change the input of flip-flop. If we suppose that we change the input from 0, 0 to the 0, 1, what happened in this case? Again, I have to calculate the next time of output when the current time is 0 and 1. If my QT is 0, QT is 0, Q bar T is 1. This 1 comes here, this 1 comes here. 1, 1, the output will be 1. The output of NOT will be 0. This 0 comes using this signal here, 0, 0, 0, 1. The QT plus 1 will be 1. This 1 again comes here, 1, 1, 1, 0. QT plus 1 will be 0. It means that if QT is 0, the QT plus 1 will be 0. Now, look at here. I clean all of these values. Again, if I set it, if I suppose that QT is 1, now Q bar T is 0, here is 0, here is 1. 0, 1, 1. 1 as input of NOT. What is the output of NOT? 0. This 0 comes here, 0, 0, 0, 0, or 0, not 1. This time qt plus 1 will be 1. Goes from 0 to 1. Now this value of this signal change from 0 to 1. If I have 1, 1, what happened? Again, the output will be 1. And also output of the NOT will be 0. Now the value of qt plus 1, the value of the next q will be 0. What happened? The current value was 1. The next value gets 0. 0. Interesting. And this 0 is stored in the flip-flop. Now, if my input change from 0, 1 to 1, 0, what happened in the case of if my qt is 0 and 1? In this case, my reset is 0, my set is 1. If qt is 0, qt bar will be 1. This 0, this q comes here, 1, 0, output will be 1. This output will be 0. This 0, look at here, this 0 again comes here, 0, and S is 1, 0, 1, 1, 0. This, now, this qt plus 1 change to 0. Now I have 0 here, 0, 0, 0, 0, 1, 0, not 1. The qt is 0, the qt plus 1 is 1. 1. Now again, if this 1 comes here, this output will not change, because we said that this value is not care for us, because this value is 1. Again, everything will set to 1. Will set to 1. Now, as the last value, if I suppose that qt is 1, qt bar is 0, here is 0, 0, 0, 0, 0, not 1. This 1 comes here, 1, 1, 1, 1, 0, 0 stays 0. This 0 comes here, 0, 0, 0, not 1. Again, in the qt plus 1, we will have the same 1 value and set this circuit to 1, and the output will not change. What happens? In the case of set 1, reset 0, I could set the output of the memory or SR flip-flop to the 1. It means that I set my memory. This is the trust table of SR flip-flop. What about What about S1 and R1? What happened if I set the input with 1 and also this input with 1? We say that this input is not allowed. Oh, how many minutes? Is not allowed. What does it mean? It means that I cannot set S1 and reset 1. I cannot set both of them simultaneously in the same time in 1. This is wrong, because I will have fluctuation in output. Okay, now according to, let's look at here, according to the trust table, according to this trust table, I can draw the timing diagram. What is the timing diagram? Look at here. I said that if my S, I have S, R, Q, and Q bar as a different signal. The S can be 0, if I set it to the 1 and again change it to S, my S is also 0, and also I can set it to 1. Here is 1, 1, 0, 0, 0, 0. Now, according to this signal, to this pulse, to these two pulses, I want to draw the output Q and QT. What happened when S is 0 and R is 0? We said that if both of them are 0 and also my Q is 0, stay in the 0. And if Q is 0, the Q bar will be 1. 1. Now, what happened? Look at here. At this time, when I set my S input to 1, this one, my output will be 1 and will stay in 1. And my Q bar will goes down to the 0 and stay 0. Up to when? Up to time that I set my R signal to 1. My R signal to 1. What happened in this case? The Q reset, the Q goes down to the 0 and stay in 0, and my Q bar goes up to the 1 and stay 1. This is a timing diagram of SR flip-flop. As an application of SR flip-flop, look at here, in the car alarm, we have the sensor accelerometer, is a sensitive motion sensor. We connect it to the voltage. In the car alarm, if something collapses to the car, this section move and push to the valve. This 5 volt cause the 5 volt signal comes to the set input of flip-flop. Now, at the first time, S is 0 and R is 0 and Q is also 0. When the motion occurred in the accelerometer, this 5 signal comes here. 5 signal means setting S in 1. Change the S from 0 to the 1. What happened when S input in the SRFF is 1? We said that if S is 1, Q will change to the 1. Q will set. Look at here. S is 1. Q change to 1. What happened when Q is 1? The alarm starts. The alarm is on. And this alarm will stay in its on mode. Stay in its on mode. Up to when? Up to we set the reset to the 1. How can we change the reset signal to the 1? Using the remote control device. If we push the reset button in the remote control, we change the reset input in 1. What happened when R is 1? The Q will be 0. In this case, the alarm turned off.